All right, I've added the agenda in the chat, and I'm guessing it's a holiday in a lot of places, so we won't get too many people, but I guess we can kick it off. Hello and welcome everyone to CDM for the month of November. And we have 3 topics on the agenda, and we already have Sam sharing the screen, I guess, so we can just kick it off with the Crimson update if that's okay. I guess so. Sam, over to you.
Yep, sorry about that. All right, this will be short. Just update you guys on some of the more recent Crimson developments. So just to get right into it, the main theme for Crimson as a whole has been stability. Radek has been working tirelessly on bug swishing in the Crimson Rados Toothology suite. So we're up to a limited selection of thrashing failure injection tests that we've all come to know and love with Toothology. And this has driven a lot of stabilization work, including some changes to the way the watch notify API works in Crimson, as well as refinements to op ordering logic, and just an absolute slew of other fixes. Oh, wait. Radek also has Crimson deployment with Rook now working. So that is major progress. And Chunmei has contributed some improvements and fixes for Crimson's Blue Store integration, which have improved performance a bit. So the next step for Crimson as a whole will be getting the scrub work moved into Crimson itself. The big original chunk of work was refactoring the classic OSD state machine, kind of like what we did with the peering machine, so that we can reuse the bulk of the code in Crimson. So the outstanding bit of work is actually doing the last step of integrating into Crimson. So Ronan's working on that when he's got cycles. And the other big chunk of work is multi-core, which Greg is going to talk a bit about after this. So for C-Store, a lot of the recent work from Intel has been adding metrics. So Yingzhen and Chunmei have helpfully added just an absolute ton of counters and histograms for counting things like transaction conflict rate, allocation information, all this stuff. It's proved instrumental in finding some performance issues that turned out to be because the allocation hints weren't working for OMAP. So everyone was getting allocated in the same, or starting at address 0, which made for a linear search for every single address over every single address so far allocated. It was quite quick to track down thanks to the counters. So that's going good. For C-Store internals, there's been a lot of work on bug fixes and stability as usual. The LBA allocation pathway got basically rewritten. My first stab at it had a couple of logic problems that were really annoying to fix. So it's cleaner now. It's kind of an iterator-based interface that makes it easier to reason about. We've implemented LBA hinting throughout all of the major components so that, in general, when we allocate a new address with an LBA space, it'll tend to be, like our guess at a free address will tend to be correct. So we'll tend to be able to do the allocation immediately without having to skip over allocated addresses. Which dramatically reduces conflict rate since it spreads update transactions over LBA space and groups them by PG. So parallel transactions from multiple PGs will tend not to hit the same portion of LBA space, which will in turn make them less likely to conflict. Let's see. We recently merged the extent placement manager from Shuihan, which was an initial step in supporting tiering within C-Store. This moves for allocating extents to this extent place manager component, which knows about things other than the journal. So immediately, this means that we can do allocations to segments that aren't the journal segment. And Shuihan is using that capability to implement an age-based binning scheme from Sprite LFS. A bit like what, I'm forgetting the name, the fast flash, no, I can't remember. A bit like that flash file system, I'm forgetting the name of the famous one. Anyway, an aging system somewhat like that. But it will also be instrumental in allowing us to write extents to devices that aren't the journal device. So this will allow us to do garbage collection from the hot device back to, for instance, a ZNS device. Which means I'll skip to the bottom part. So the other piece of this is multi-device support, which means that the internal addressing in C-Store has gained some bits that allow it to designate up to 16 different devices. so that a single C-store install can have multiple devices. The first PR for that is merged, so that bit of the data structure exists. There will be follow-on patches adding actual proper tiering heuristics, although I expect that will be rather a long journey. We also reworked the way conflict detection works. All internal things use interruptible future now. So rather than at commit time having to iterate over the read set and check whether all of the extents are still valid, instead, when we invalidate an extent, we have an intrusive linked list for all transactions currently referencing it, and we immediately mark all of those transactions conflicted. So when the interruptible continuation, or when the interruptible future resumes, it checks that condition and immediately bails, which saves a lot of wasted work. It's also a little more efficient since we don't actually have to iterate over the read set in the success case. It moves a lot of the work to the invalidation case. And even then, it's proportional to the number of other transactions accessing the same extent. So more efficient. So next steps here are we need the ability to remap the location of logical extents because we need to be able to do that to clone object data. This is going to be a substantial bit of work, and it will likely need a parallel structure to the LBA tree structure, representing a reverse mapping from physical offsets back to logical offsets. I haven't quite worked out how I want to do that yet, but that will be a thing.
Can I ask a really quick question about the conflicts?
Absolutely.
I think you've explained this to me before, but I've forgotten. Can you remind us why the conflict detection is necessary? Because in other systems, that isn't usually an issue.
In the limiting case, you could have a different metadata tree for every PG. And in that case, there would never be any conflicts. But because of splitting and merging within the onode tree, it's possible for parent nodes within that tree to be accessed by parallel transactions from multiple PGs.
Mm-hmm.
Does that make sense? There are other ways to do it. We could add a scheme. We could add
or something at the end. Like, why wouldn't? I guess there's no locking. I guess on the.
There's no locking at all right now. That's the win. The win is that there's no pessimistic locking.
Okay.
So in theory, this permits concurrency in cases where otherwise we wouldn't be able to permit it. If we had to lock on the way down, we would have to be really careful. We would have to do like one of those schemes where you like read lock on the way down, figure out what you need to do, then retake write locks back down to the possible but complicated.
Right.
We can fall back to that scheme if we need to, and likely we will. But the fact that we allow retries in the first place means that we can use a locking scheme with conflict detection back off. In other words, a scheme where we permit the possibility of a deadlock, but do deadlock detection instead of needing to do deadlock avoidance. So even if we do end up doing that, this mechanism will still be useful, since the hard part wasn't so much the transaction conflict detection part, it's the retry part.
And the transactions are independent. There's no read side, I guess, in these transactions. They're because there's already isolation. Is that the idea? So you can retry them.
These transactions do have a read side. So we track the extents we read. And that's important because there are a lot of edge cases in split and merge where you modify a child adjacent to another child modified, where you like deleted it. Maybe I'm misunderstanding the question.
Yeah. Okay.
In the event of a read, we don't strictly speaking need to remember the read set, and we don't strictly speaking need to validate it, since most reads are point reads. But if you did want to do a transactional read of multiple points in the tree and get a consistent answer, this does support that as well. So either way.
Okay.
So far, I've been trying to sort of get as much as I can with like one really simple mechanism. We can add faster degenerate cases later as needed, but fewer code paths means less review.
Cool, thanks.
Yep. Let's see. This is the last page. Okay. So tiering, like I said, is a next piece. I think Xuehan and the folks at Samsung, yes, are also working on this sort of from two different angles. Xuehan's looking at it for tiering back to hard disks. The Micron folks are looking at it as a way to do faster, true random access storage as a sort of a faster tier, or as the sole tier, depending. I think I think as a faster tier is going to be the vastly more likely use case as ZNS becomes more common. Because with some of these devices, we really will need a faster tier. So one of these fast random access devices will be good for that. That is things with like byte level updates like Optane, or in the limiting case, persistent memory. Another major piece is Enos Enablement. Joseph is working on this. We're actually getting pretty close. He's got most of the interfaces implemented. Mostly, I think he's trying to make sure he understands what all of the relevant IOXLs do. So getting close. C-Star itself already had the code. A Samsung engineer already contributed the code to C-Star itself to enable the relevant IOCTLs. So passing the IO commands through is possible. It's just a matter of wiring it up to Segment Manager. And finally, the last piece is adding debugging tautology tests. Crimson with C-Store. Chunmei's actually picked this up, so she's made a lot of progress.
Should FADM support be on here? Since we have work running it now.
It should be, but it's not. Yeah.
Okay.
That's the next piece for sort of usability stuff.
Yeah. I was just pondering this a little bit earlier. It would be a lot easier for Ceph ADM to manage this if it were the same container image that had a Crimson binary in it as well as the non-Crimson binary.
Yeah, I believe
practical to do that or not.
The thinking so far has been it's just different containers, and the one for the container is just called Ceph OSD. But I agree with you. I think it would be better if there were like a well-known, I don't know, if every package had both. We had Classic OSD, Crimson OSD, and Ceph OSD, which is whatever the current default is.
Yeah.
That seems sensible to me.
So Sam, as far as the Rook integration goes, I think that is complete, right? I mean, we can start up an OSD, run IO, everything.
Yeah, I think he's got it done.
Awesome. So I guess the next usability piece is Ceph ADM, and maybe this is an opportunity to maybe add tautology tests which are directly based on Ceph ADM as well in the Crimson Radar suite.
Yeah, that would be a really good thing for someone to work on. It'll be me at some point, but if someone else wants to work on it sooner, that would be good too.
And I was just thinking about one more aspect. So in terms of the OSD ops piece, so we've got like recovery backfill figured out. We've got peering figured out. It's basically scrubbing that we've already started working on, and like snapshots that you just talked about. So those are basically what we are looking at, right?
Snapshot has sort of two pieces. C-Store itself needs support for snapshots, so that's one part. But Crimson OSD, the top end, doesn't have any of the logic for handling them yet. So the I/O path for
that needs to be.
Yeah. Okay. So that will work correctly with BlueStore once it exists, and then also with C-Store once the C-Store side exists. But the C-Store part isn't a blocker for getting snapshots implemented.
Got it. And one last question I had was, I know somebody was working on integrating RGW object classes with Crimson. How far did we get with that?
I kind of remember that. It probably just happened.
Okay.
The RBD one's already done, right?
Yep.
Yeah.
Yep.
Okay. Was that a matter of adjusting or refactoring the existing classes, or do you have to like duplicate them and use a slightly different framework or something?
No, I believe what's going on here is that for the most part you can use the existing classes. It's just that not all of the API methods are implemented in Crimson yet.
Right.
This is the PR for it. It doesn't look like it's merged yet.
Yeah.
It hasn't been as much of a priority simply because RGW is a less obvious demo for Crimson being useful, but it is definitely useful.
Okay, cool. Thanks. I just wanted I knew there was some work going on. I just didn't know what the status was.
Yeah, this
Yeah,
should get
yeah.
finished. It looks like it's pretty close. Let me add this to my
Mhm.
notes.
Excellent.
My brain is still stuck on the container thing. It seems like that would be simpler if we changed the way that the makefile was structured so that when you just do a normal build, it builds both all the regular stuff and also the Crimson stuff in one pass. So that when it gets to the packaging stage, it can, I don't know what we want to do for packages, whether there's going to be a Ceph OSD and a Ceph OSD Crimson package, but it could do it all at once and then produce a container image at the end, as opposed to
Yeah.
having like a different define that you load in the front end and having a totally different job to do it. You know
Yeah,
what I
that
mean?
makes sense.
Yeah, okay.
Truthfully, I don't remember what the reasons for doing it this way were originally. My instinct would have been to just build all of it in one pass.
Yeah.
I agree with you.
Okay.
I think this
Yeah,
made
and
it
also
very marginally easier to get it to work with Rook because it meant you could just call the exact same binary or by name, then it would just work.
yeah,
But I
because
don't think
otherwise
that's
there
a
are two
trade-off.
images. There are two images
Yeah,
you have to keep
precisely.
track of, which seems bizarre.
It's more difficult to handle upgrades too. It's just more complicated in general.
It would be also nice if developers, when they're just doing a build in their local dev copy, would build both the classic and Crimson at the same time instead of having, because right now, like you can break the Crimson code and not notice until you push it, and the
Hmm.
GitHub CI tells you it's wrong.
It takes a
All
noticeable
builds
amount of
everything.
extra time. I'm not sure we want to just always build it.
Well, I mean, all does build everything. So I think
Yeah.
it's more that it needs to be one of the more default targets. If you want to build less, you can always build less on purpose.
Yeah, yeah,
Like it's not like it would build Crimson if you tried to build RGW, right?
yeah. And when you build Crimson, I mean, it's just the OSD, right? There's no other
Yeah,
target
that's it.
really. Yeah, that shouldn't
There
be
are some
that.
ancillary tools, which actually I'd kind of also like to get built, but because those tend to get broken when we change Crimson code.
Yeah, but yeah, I wouldn't expect it to be too much.
Well, it's because you have to like recompile a bunch of the common and core code. Like you're compiling two instances of mon client and stuff.
Right.
So I haven't timed how much longer it adds on its own, but it wasn't trivial.
The thing is, though, that's the stuff you tend to break by accident. Oops. Yeah, there we go.
Yeah,
That's the part
yeah.
you tend to break by accident.
Okay. The other thing that I was talking to I think Mark about this, the perf CI that we had for Crimson, it's still functional, right? Or Crimson PRs. I haven't looked at it recently.
I mean, mostly, but all it does is run Rados bench. It's not like it'll catch a gross violation, but that's kind of it.
Okay. Yeah, the reason I'm talking about it, I wanted to revamp that a little bit and just not just for Crimson but for most PRs. We're probably going to discuss that at the performance meeting tomorrow. We have a person who has some experience with building some performance automation tools, etc. So maybe we can discuss with them.
Yeah.
Just a FYI. So what do we have next, Greg?
Sure. I did not make a presentation, sorry. So I've not gotten as far as I'd hoped to when we scheduled this because some things came up. So instead of having some like big progress, it's mostly just a pile of questions and some goals. But I'm trying to work out how we want to do multiple or multi-core Crimson. And let's see. So sort of the obvious thing is that we have a messenger, and we can bring in messages, and we can send those messages to PGs, which can be on different cores, and the PGs have to do transactions, which can be on different cores. And the messenger can be multi-core if we have a way of directing them appropriately. So I've talked about this with Sam, and at some point it would be very nice if we could just tell Crimson that we want to use 6 cores or however many cores, and the client's direct messages to the right core that's just listening on different ports or something, and those go to the PGs that live in their cores, and those go to object store state that lives in their cores. But that requires, clients that know what's going on and changing and changing the OSD map structures and inflating them somehow. And we're always going to have old clients, presumably, who don't know that, so we can't rely on that. So the first thing I want to do is get it so that we just can have a front-end messenger, and it can parcel out to PGs that live on different cores, and then those PGs can funnel to the appropriate object store, which initially will just, again, be back on one core. So it probably won't actually be very much faster for me going, but can at least demonstrate that the cross-core communication functionality works. And I mean, these are the same sort of crossbars that we have in the classic OSD, but they look a little different. When you submit a client request in Crimson, then it actually the operation starts itself on the OSD. So I'm exploring how we can try to handle the memory allocation better. And if it's possible that we can only decrypt or decode the operation enough to know which core it needs to go to, and then have that core decoded into its local memory, so we don't have as much split memory communication happening. Luckily, it looks like that in terms of allocation isn't going to be a problem. That was one of my concerns, was just that if we have operations crossing cores all the time, then it'll fragment the allocator pretty badly. But ScyllaDB does not seem to be concerned about that. They just generate function pointers, they generate foreign pointers for literally every message that comes in before they direct it down. So that seems like it'll be okay. But then, we shard the PGs across cores, and I mean, once you're within a PG, then that's logically pretty simple. It's just about having the right interfaces. I don't really know if there are questions that people or things that people are concerned about, but
are you looking at on the C-store side too, or is the idea that once it gets to C-store, it's all back on one core? Is there shared?
I've discussed it with Sam, but that's not anything I'm going to be working on, at least not in the near future. I think he had many ideas, which we've talked over, how we want to do that to shard C-store.
Yeah, in the extremely short term, it can be a static sharding where we just run n C-star instances with some kind of a really, really coarse way of allocating big old chunks of disk between them. It gets more complicated when we want to be able to support split and merge and dynamic assignment of PGs, which we do. I have some thoughts about that, but it's pretty complicated. Basically, all of the data structures need to be ordered in a way that allow us to grab a subtree corresponding to a PG and stick it on another core, which has a bunch of knock-on properties.
Yeah.
I don't know. That's TBD.
Do we have any sense of how many cores we'll need to sort of service a single device?
No.
I would imagine for the bigger ZNS devices without any couple high performance whatever, then one core is enough. But
I'm not sure that that's the interesting metric, actually. So I have this sort of model for Flash devices in my head, which is that they have however much parallelism they have, and they take up however much bandwidth they take up. So in an ideal world, if it takes 4 cores to saturate a device and you have 32 of them, you just have 8 devices. And whether you run 8 OSDs or a smaller number of OSDs will depend on what the most efficient way to set up C-store is. So I don't know that we actually want to be making assumptions like that just yet. I think the assumption needs to be that C-store will partition up devices however it does it, and we need a way to move stuff between devices, or between cores. I don't know, not a good answer, I know, but It seems like the only
Was
design
that
choice
actually
here
your
is
question, Sage? I'm not sure.
Well, I mean, I guess there would be an easy out if we thought that the fastest device could be serviced by one core, but
right.
I assume
I
it's
don't
clear
think
that
that's
that's
true
not
though.
the case.
Yeah,
Yes.
this is what I'm
I
saying.
don't remember the
I
exact
don't.
numbers, but we know that that's not true.
I think C-store will end up being a significant percentage of the overall CPU usage in retiring the write to disk. So, yeah, I don't think so.
Okay.
I think as like we can seriously change the ratio, which is the entire point of Crimson, of course, but devices are so much faster than Classic OS
Yeah.
can currently service that I don't think betting on a single core is a good idea.
Yeah. Yeah.
But I think we can get a lot of mileage out of the static assignment thing, and like some problems are just actually kind of hard. So that one will take some thought.
Yeah.
But the static assignment thing
I
will buy
mean,
us some time.
it seems like the easiest part is that if each writer has its own zones or whatever that it's writing to, and they're all independent, but they need to be able to read and hold references to things that were previously written by other zones. And so if that framework can be
The
built
problem
up,
is the metadata and allocation structures as well as garbage collection. You'd ideally want each of these cores to be able to do local garbage collection. So
yeah,
that's the hard part. Like the IOs themselves aren't really a problem. Like whatever. But accessing an O-node tree that's held in common by all cores, that's much harder. Because
yeah,
it means that it's being mutated by multiple concurrent journal segments, which means ordering is complicated.
yeah. Although they would be
Logically.
modifying different regions, right? Like they're constrained to their
Yes,
PP
precisely. Hence
intervals or
the
whatever.
that's the sort of distinct C-store model, where each core essentially gets its own little C-store and
Yeah,
really big gross divisions of disk. And then if we do need to like move a PG between cores or something, in the meantime, we can just route the relevant IOs back to the correct core.
yeah, yeah. Or like force a split on some random whatever pages so that the PG boundaries are like the edge of the PG doesn't map across.
Yeah,
the
so
core.
that's
Okay.
the real solution. That's what we need to do to solve it for real. It's not that hard, but it means that all of those data structures need to behave like that. So it's
Yeah.
work.
Yeah.
But I think that is
Which
indeed the end point.
is what
You
we
make it so that
discussed.
you can extract arbitrary subtrees and paste them into a different core's tree. The only hard part is that some of the data will exist in segments that are ostensibly owned by another core, but that's not a huge deal. You just track which segments
Read
have
only.
multi-core ownership. Yeah.
Yeah. Yeah.
So from a hand-waving level, I think it's very solvable. It's just work. In the meantime, we can do the
Okay.
static partitioning thing. And
Okay.
Yeah. I think the main reason that's interesting is when we start worrying about things like RTW, where you might need to make sure that, all the index bucket PG or the bucket index PGs are on different cores or something. But while we're focused on RBD, we can basically assume every PG is going to have equal heat.
Mm-hmm.
I mean, even that's very solvable. Once you have the ability to move PGs or have PG localization information, period, you just look at the pool and go, oh, this is apparently a performance pool. I'll put it on a performance core. No biggie.
Yeah. Okay. Cool.
Does this seem like an insane way of doing C-store? I feel pretty unmoored from other design strategies at this point.
It makes sense to me.
That's good.
I guess the part that makes me nervous is what the interim static mapping thing is. Just making sure that that's gonna be in the right direction, and not be a cul-de-sac.
Oh, I mean, that was gonna actually just instantiate when you make a fast the OSD, you tell it you want 5 cores. It creates 5 these stores, and it writes down on the first one which PG gets mapped to which one.
Yeah.
That's as far as I was going to take that one. The allocator part, where you need to be able to allocate big chunks of the disk to different ones, that's that's the step 0 of supporting it for real. So I don't think that would be wasted work either.
Okay.
I think.
Okay. Greg, did you have anything else, or?
Not really. We want to move on to telemetry with the 5 of us.
Yeah, Yarit is here, so hand it over to her. Yarit, over to you.
Sure. Hey, everyone. So yeah, the first topic is about the re-opt-in flow that we're trying to solve an issue with the current design that right now when users opt in to telemetry, they basically opt into a version of telemetry, which is currently 3. And of course, they need to explicitly agree to send the data. And if we want to introduce collections of new data, we need to bump that version, which means that the user needs to re-opt in. And it means that if they don't, they stop sharing the reports with us, which is not ideal. So we had all sorts of ideas of how to handle it, but eventually the design that made the most sense to me was to have like a collection or a metrics data structure on the module, which will be written to the database once the user opts in. And this way we know to have the diff pretty easily between what exists currently in the module and what exists in the database that the user gave their permission to send those metrics. Still works in parallel with the channels design that we have, that we only send information only if the channel is turned on. So this still is still the same. And this new design basically allows us to backport changes easily and to introduce new collections to existing channels already. And we can show the a preview for a report that the user is already opted into, and a preview of the next version, like with a telemetry show and telemetry show next, because we will have whatever is already opted into in the database and whatever is existing in the module. So yeah, we just we discussed it on the previous CDM, and since that in our telemetry huddle. So just wanted to give an update on that. So does anyone have questions about this specific topic?
Yeah, I guess the idea is, I think we all agree, is a good idea, given that we want to add more information to channels that people already opted in. So I guess for a user, so you said that the current telemetry version is 3. So what happens when Quincy comes out? They will continue to use 3, and 3 will have some extra data they'll be sending, and do they have a step where they seamlessly do this right after upgrading?
Yes. So there's one step after upgrading that if the user is opted in already to 3, we will have these as the legacy collection, and we will continue sending those metrics. And in case they re-opt in, we will sync with whatever will be available in the module at that time, which the diff right now is the perf channel. So So we will just add that in case they re-opt in. If the user is opted in to version 2, we will not update in their database those metrics because they regardless need to re-opt into 3. So that's that's a design. Yeah.
Okay, that's the re-opt-in step is what I wanted to. Okay, got it.
Mm-hmm. Yes, it's. I tried to implement the previous idea and it was too cumbersome. So I feel this is a lot elegant. So.
Yep, absolutely.
Cool. And okay, so I guess we can move to the next topic.
Unless anybody has any questions.
Yeah, sorry.
Yeah.
Nope.
Okay, I think you can go ahead, Yarit.
Yeah, okay. So I'm glad that Greg is on the call because you had some concerns about ideas for collections that we had. And I just wanted to say that I updated the CDM doc with an Etherpad that Laura prepared for today. She compiled a lot of notes that we had from all sorts of Etherpads and Google Docs and etc., which is awesome. So thanks, Laura. So I was curious, Greg, if you can tell what exactly are your concerns about collections. Specifically, that was we mentioned the OSD epochs, and in the next performance, in the next version that we're going to have for Quincy, we will be collecting a lot of performance metrics. I can share this Etherpad that has an example for telemetry report. It's very simple. It's from a vStart cluster, but you can get an idea for all sorts of metrics that will be collected for the perf channel. And it will be also per PG counters. And that's because when we talked with Mark and Adam, they said that it made more sense to have better resolutions of these metrics. So, and of course, the idea here is to have these changes run on the LRC and to review those metrics and see if it makes sense to collect metrics separately and aggregated at the same time. But I'm very concerned with concerns about collections. So if you can share your thoughts, Greg, that'd be great, please.
Oh, I remember mentioning that sounded more intrusive than what we currently collect, but I don't remember if I had any specific things. Part of it is just that the more we collect, the more careful we need to justify to people and make sure that it's not de-anon, that it can't be de-anon. Man, how do you say the word? That you can't make it unanonymous. And there's a little more in here that I remember just having, but most of what we collected so far is about the the versions of things and the parameters of stuff that we mostly set by default, right? There's like sort of the thing most likely to be set here is, oh, okay, so we're talking about the number of RED pools and things, I guess, is what we collect right now. Whereas once we start collecting like the epic generation or like the generation of epics, then we're getting into knowing how quickly a person's cluster changes and how healthy it probably is. And there are all kinds of reasons that is like incredibly useful information for us as upstream developers to have, right? Like if we know how, like we can tell what state people's clusters are usually in and what sort of situations we should be targeting for. But it also means that it's probably like if anyone ever figures out who owns a particular cluster, then they have a lot more information about what that person's thing feels like. And if we're like collecting performance statistics on a per PG state, then like anyone who runs a proprietary RTW cluster is definitely not gonna share that data with us, because they're not gonna want people to be able to see how they're like, or like what they're supporting for their external users or their customers or whatever. And I mean, maybe that's okay. Maybe we want that data, and so reducing the number of clusters we get is fine. If we get that data from some clusters, I have not thought a lot hard about this much, but like I just wanted to make sure that someone was thinking hard about it.
I guess there are telemetry huddles happening every week because you're thinking very hard about this, and
Probably.
I can see that.
I just happened to see one. It was like, whoa, that's different.
I mean, what my take is, I mean, how healthy a cluster is. I don't see why people wouldn't want to share that information. I mean, like that's something that we want to improve, right? I mean, we care about how healthy a cluster is. There was another thing that came about.
Well, I mean, yeah, we care about it, but people might not want to share it because it exposes how their operation works. That's
why we have something called opt-in, right? I mean, we tell them what we
collect. But that also means that we're going to lose all of the data from those clusters.
No. That's not
the
how
idea
it works.
Of channels, right? There's that.
Yeah,
exactly.
Yep.
I think
exactly.
I have kind of a similar concern, but it's a little bit it's not specific. I don't think that there's anything in particular wrong with like any specific field. What worries me is that when you look at the perf dump, it's like it looks like there's just a PG dump included in here. It's like everything in the kitchen sink is sort of dumped in just because it's convenient. And I think we should flip it around a little bit, and so that instead of saying like here's all this data, is there anything that we don't want? Instead, we should think of it in the opposite way and say like what is it specifically we want to learn, and what is the clearest way to include that information. So for example, if we care about how healthy the cluster is, don't say that that's why we want the epics and we can infer from that, but instead have a section that's like explicitly describes the information that we want to know about how healthy the cluster is. So for example, have a histogram of the PG states or something like that, right? Or if we want to know about the OSD logs, then we could have a section for that. Like I wonder if almost we should flip it around. Sorry, hold on a second. We should have it so that there's like a for every given like section or field, you should be able to like write a sentence or a paragraph that says like what this is and why you include it and why it shouldn't worry you that it's included, something like that. You know what I mean?
Or why it should, but why we'd really appreciate it if you would let us have it anyway.
Yeah, I mean, I feel like it'd be easy to go back and write that for all the existing stuff that's in telemetry, right? But if you then go to like, or like even like the OC perf histograms, like this is a section that was like specifically constructed for the purpose here, and you could write something that says, here we want to see what kind of latencies users are experiencing and how big their IOs are. And you could like write that and say like, you're like, great, that's it. I can understand why developers would want to know that, and I can see that this information is what that is, right? But then if you go further down in this dump, you see the PG dumps, and you're like, or maybe the perf counters are a little bit tricky because you have to like think about what they actually are measuring. So that one is a little bit harder to justify. But if you go down further, you just see like the PG dump, And this is like every field in these structures. And, you know, most of this is like individually it's not useful, but also it's like they're timestamps with like nanosecond precision. Like there's no reason why we need to know that, right? And so it should be the other way around where we're like, we want to know how big the PGs are, or we want to know how big the logs are. And so you have like a sort of a summary that like picks that particular thing out.
I think that's where we are getting at with trying to, like, this code is not going to go out without us trying it out and then creating this summary that we really want. That's the whole point of installing this in the LRC. So this is just the raw dump. Okay, we also don't know what we want yet, to be very honest. So first we look at the realistic data, we figure out what that good summary looks like, and start with like some subset of it. Yari, correct me if I'm wrong, but I think this is what we agreed to. Like, you know, this is, you know, the idea of like, first let's just throw everything and see, you know, which of the we actually can make sense of. And then we as developers decide like, okay, this is a summary that we want, and then we roll it out to users. So I guess and we need to be very cautious about, you know, as I keep saying, we don't want to collect anything that we're not going to use, or like we cannot make sense of later. So we need to answer that question right away before we even ship it, that, okay, we are going to use this and in this ways, or in one particular way. What can this help us answer or infer? So I guess those questions will be answered, but as going back to Yari's concern about, you know, security and like what is safe, not safe, I think if we do this due diligence of looking at each and every field, we are being very, very cautious, in my opinion.
Yeah.
Mm-hmm. Yes, that's the purpose behind our best efforts with the run on the LRC, to see what we can infer from everything collected. And of course, we cannot foresee the future and think of metrics that will eventually become useful, but maybe it's better to err on the safe side and collect less and then
and to be honest, there's no perfect answer for this. It has to be like incremental. We learn from our own mistakes and we learn from what we did not collect and we need to collect next time. So it's like an iteration in my mind. So as long as we're starting with something and we're doing due diligence as to what we want to get at the first go, I think we should be good.
Yeah, agreed.
Yeah, sounds good. And Greg, I'll be very happy if eventually you'll review those metrics as well, if you feel like it.
Sure, just tag me on the PR.
I have just one other thought. I think that maybe another way to look at this is from the perspective of the operator who is trying to decide whether to turn this on. And so they go look at the telemetry dump. If they're looking at this dump that's just all these fields and they don't know what any of it means, or they have like huge grids of numbers and they don't know what it means, then it's like very easy to imagine that there's like information being hidden in there, either deliberately or accidentally. Whereas if it's structured in a way that like picks out exactly the high level meaning that we're trying to derive from it, and the fields are sort of named appropriately, and it would be awesome if it could actually be like commented. You can't really comment JSON, I guess, but then it would be easier to review, and then people would be able to actually turn it on. But so far, the people I talked to they just don't know how to audit it, right? So
we could publish a schema, something with an explanation of what the fields mean.
Yeah.
Mm-hmm.
Yeah.
Would you do that on like on what level? Like on the collection level, or like on the very basic key value level?
Ooh, I don't know. I guess it depends on how much work it is, but I would.
Yeah.
Well, I mean, just thinking off the top of my head, we could make some documents in doc/telemetry with just like like an entry for each channel with like a JSON description of what would be in it, and then we can update that as we update the versions. It actually has a side effect of if someone opts into version 3 but not version 4, we could just not populate the fields that are different, so we could keep the schemas themselves versioned.
I wonder if. Sorry, go ahead.
Sorry, I didn't get the last part of the sentence, Sam?
It just occurred to me that depending on how much work this is, you could do something like if the code internally, when it's projecting the information that it's collecting onto the schema that it's going to emit to the telemetry platform, it could keep versioned versions of that projection. So if someone opts into version 3 but hasn't updated to version 4, we could continue sending the version 3 version.
Yeah, yes, we will send the version 3, and basically after version 3 we will not have version 4. It's like a virtual version 4. It's like whatever we will add to the like that collection data structure on the module will be that version. So yeah, but then of course we will add the explanation for these metrics as well. Yeah, there's like a description field for each of these, but it's on a high level for each collection. Sorry, Sage, what did you want to add?
I was thinking that it would be cool if the sort of the prose that like describes what we're collecting and why could be embedded in the code itself as a comment and annotated in such a way that it specifies where in the eventual JSON structure it shows up, so that later when you generate the JSON, you could generate an annotated version of that then includes those same comments. There's probably a lot of like wiring together to make that. But I could imagine somebody like, they do this initial review, they're like, okay, I'm comfortable with this. And then they like, with each release, they can look at a diff of manager telemetry and they can see what changed, and that could be part of their like re-opt-in process. You know,
yes.
What I mean?
Yes. So I did think of that on the on the collection level. So for example, if we now add the perf channel, we can add like the initial perf collection, which would be right now it's like certain like multiple keys on the root of the report, like stats per PG and OST histograms and so on. So that basically is like the initial collection for the perf channel, and if the user opts into that, so we have a description for like a general description for that, but that's not a great resolution for these are not it's not very detailed. So we can break them down. We can break them down to each one of these collections and have like a description for each one of them. And then when we show the diff, we can show the descriptions for the differences between the versions. And if you want to show the actual metrics, we can print the actual report. But you're saying that it should be a report which is annotated, if I understand correctly.
I mean, that's a pipe dream. It would be nice.
Okay. Yeah.
I mean, it would be. I guess the best case would be that the raw JSON was structured in such a way that you could intuitively see by the naming of the elements like what it is. But I have a feeling that's asking a lot. It would be nice if JSON supported comments, but JSON does not. Although maybe there could be like a variation of it that could like add comments, so it could embed stuff in there. And then separately, it'd be nice if somewhere we should actually like try to write down why we're collecting each thing and give sort of some justification. Maybe the source code is the most reasonable place to put that. Maybe I'm not really sure. But in any case, it would be nice to have, if we think about the person who's trying to decide whether to opt in or to re-opt in, like think about what would make their job really easy, I guess.
Yep.
Whatever we can do there.
Yes, that was my concern as well, that people could be cynical when they see all the huge amount of like perf counters that we're collecting and might be too paranoid to share it, even though it's all anonymized and we're doing it to improve the quality of the product. Yeah, okay, so we need to find an elegant solution to describe the metrics that we're collecting, either in the source code or in the docs, or both.
Okay.
Yeah, 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 thinking.
Yeah, Yari, the more I think about this, I think the sooner we try to install the thing on the LRC, the more answers we'll start to get and better direction, I feel. So let's do that, maybe as soon as possible.
Yep.
I already saw that Laura has a backport ready, so we can figure out whenever she's ready to, go ahead with the install.
Yeah, I think maybe there are a couple of more PRs. Yeah, and there'll be maybe one or two about probably RocksDB counters. But yeah, I guess we can start with something.
Absolutely. Yep.
Yeah.
We can do further upgrades, right? That's okay.
Yeah. Yeah, and
but the only, I mean, like just talking about the specifics. So we will not be shipping the code in a specific point release, that we are clear about, right? We're just backporting it, installing it in LRC, and then rolling it, or like just letting it be in the LRC or something like that, just for experimentation purposes.
That's a good question. Initially, we said that we're not going to backport the perf channel.
Yeah, I mean, I don't see a reason for us to backport the perf channel for any point release. It should go in a major release, which is Quincy, which is fine. So I think the easiest way to go about this is just pick a time to merge this in, or merge this in Pacific, install it, and then maybe revert it, and then install the new version. That can be one way to go about it.
Yeah. You need to revert it or merge it in. You can just have just base those patches
on top of
all that.
Yeah. We can talk about those specifics. Those are details. Yeah. We can.
Yes, one of the ideas to switch to the new design of the re-opting in was that we wanted to make sure that we can backport collection of new metrics as well, because otherwise we'll have outliers in the data. For example, if we now we collect a new metric just in Quincy, and we want to compare it to other versions, it will not be there because we never backported it. So it's either as long as we remember that it doesn't exist in older clusters, so there are no outliers in that sense, or we decide to eventually backport new metrics. But of course, we can decide on that later.
Good. Okay, anything else on this topic, or should we go on to the last topic?
So Laura had some questions about collections of new metrics. Some of we talked about already, but I don't know how long the other topic can take, and it's late, so maybe you can come back, whatever works. Or
if it's It's fine if it takes a few minutes we can spend on the telemetry topic, and then I don't think the last topic is going to take too much time. So you can go ahead if you want.
Yeah, so one question was about how we detect availability in the cluster. There's that Trello card that says created, and is that. And she had a couple of questions. So first, how do we aggregate such metrics over time, and whether we need raw values, or can we just report the information at a high level? But again, this, yeah, if this is not super urgent, we can always discuss this.
Yeah, I think this goes back to Sage's earlier point about, like, not capturing every PG's state, but just seeing what the distribution is, and then the next level is what the distribution is over time. So if we create a summary of total number of PGs, how many PGs are active clean over what amount of time, that will give us a rough idea about what the availability of the entire cluster is. So I think we need to go into specifics into, like, how that aggregation, or how we want to do it, or how much time, etc. That logic obviously doesn't exist, but I think that logic is also useful not just for telemetry, but maybe even having it in like a cluster report or something like that. At the moment, we don't have a good picture of what the availability has been over time. We just have like cluster logs which tell you what has happened only over a specific amount of time. So I think that's a common topic in my opinion. It's not just a telemetry topic. If we have something, telemetry can definitely use it.
Okay. So that, yeah, and that would take some more infrastructure work.
Yeah, and just to add to this, I think you're already aware that Prashant has been doing some aggregation of even the slow ops. So like historically, we've been logging every slow op that we ever have had in the cluster, and like, and other problems associated with that. But what he's been trying to do is summarize the slow ops over a period of time, so that we don't log every op, but we have a distribution of what kind of slow ops are there in the cluster, and even like, in which host, which rack, which OSD. That kind of summary will go into the cluster docs. So this kind of ties up with that, I feel. So we can discuss it in a separate meeting and see how we can make progress on this.
Cool. Sounds good. Yeah. So I think we can go on and discuss the other issues offline, if that's fine.
All right. So I think the final topic is about notifications about critical issues. So we had the motivation was over the years we've had these critical, as in data corruption issues and things that can bring down your entire cluster kind of bugs that we try to let people know by means of mailing lists or docs, etc. But there was a good proposal that came in this Ceph leadership call about having a health warning that could alert users if they are prone to any kind of critical bugs. So there is this tracker issue, which has some ideas already. Pasted in the chat for everybody. So one of the ideas was that if running version has a known issue, we have this kind of a JSON which has like versions and critical issues, a mapping, and then a health warning would be generated if a user is running this particular version. That's the general idea. But I saw another comment from Ernesto was talking about a manager module called feedback. And I'm not entirely sure what that is. But there is a pull request linked there, which we can probably take a look at. I guess the general idea is the same. Anybody else have any idea about this feedback module? Just from his comment, what I'm understanding is basically so it's going to be using Redmine, and whatever we flag in Redmine, it is going to raise a health error or a health warn or whatever based on what criticality the Redmine issue has. I guess, I mean, yeah, we have to have like a really severe kind of level for, like, currently we have what urgent. A lot of bugs are urgent, but probably doesn't matter to users. We have to have something specific in Redmine if we want to use this model.
Yeah, this shouldn't be an automatic thing based on a bug simply having a particular severity. Someone, probably the lead of the component, should probably need to mark it as flaggable. But the rest of it I like. Like, we've had occasional blue store problems where it's very important that you know that this is a thing before you try to upgrade.
Yep.
I'm a little worried about disallowing installation of marked versions, though, because it'll break automation. The severity of the bug may not be higher than the danger of being unable to introduce a replacement OSD.
Yeah, you could have, there could be like a warning or a force or something. I guess. I
think of logging is correct. I think it should like loudly warn or go into health warn or something.
Yeah. This reminds me of the feature we recently added to Ceph ADM where you can do Ceph or upgrade LS, and it will list all the available versions in the container registry that you could upgrade to. And then this, which the current implementation looks in the registry and it looks at the tags and tells you what versions or tags you can use. But the original idea for it was actually to look at this releases.yaml file, which we already have in the tree that includes the date that every release was released and also what the EO end of life is for each stable series. It makes me wonder if we should have something that almost combines the two so that the cluster could reach out and look at this releases.yaml file. And this could be where we would mark that, for example, this is a toxic release, or it has a particular label or flag on it that says it has a data corruption flag, or it has some, who knows, whatever annotations we decide make sense. And then when you, from the cluster, if you list available versions, it'll show that information. Like, these are the available versions that you can upgrade to. These are the flags that are on them that, for example, say don't install this one. It could even say what the end of life is for, although it's not per point release, it's per stable series, so maybe that wouldn't make sense. But it could have like when it was released. I'm not quite sure what other information we put in there, but then you could have, yeah, I don't know. Yeah, it is. You would need that raw data in order to have a feature where you would raise a health warning if you have a problematic release, right? So we could warn if the release is approaching end of life, for example. There was a sort of a similar idea that we had a while back where if you have, if your cluster has seen certain crashes that are referenced in the tracker and like linked as fixed in a particular release, then it could tell you that you've experienced a crash that is fixed in a subsequent release and maybe you should upgrade. Maybe that's a little bit.
Yeah.
That seems really hard.
Just because you haven't hit the bug yet doesn't mean that you don't want to avoid it. Perhaps, but I don't know. But I guess if we're gonna programmatically label releases as bad, we should decide what those labels are, and they have to be put somewhere. And so we might as well put it in a location like this that also has all the other information, metadata about release that we can gather. So there's one central place for it. And then by default, the cluster can go pull it from whatever, from Git, or whatever. And if you're on a private network, then you could mirror it locally, or you could configure some other location to pull it from. Yeah. Anyway, that's my thought.
If I'm not mistaken, this releases.yaml is the one which is the raw data for even the tables that we have for like what releases are there. So if we have some extra fields here, that could also reflect in the corresponding docs.
Yeah, and that same or similar information could be presented on the dashboard or via CLI command.
Exactly. Yeah. Yeah.
Yeah.
Okay. Okay. I think we all agree it's a good idea. We need to just write it down somewhere. Like maybe I'll update the tracker with what we discussed and like, get somebody to work on it. Any more thoughts on this? Yorita, does this tie into the telemetry story at all, or because a lot of these issues may not have crashes or like one particular crash, so that's one of the problems. So that we cannot like collate all the crashes and say that okay, this bug. But in some cases we can. For example, for the first data corruption bug, there were multiple symptoms. One of them was a crash, which I at least found in telemetry, which was good. And there was not only one cluster experiencing a lot of those. So that was, I guess the impact wasn't too bad, at least for that crash. But yeah.
Yeah, so my thought on that was that we have the crash signature on the client side, which is like the V1 version of the signature. And in order to understand that it's the same crash that was reported through telemetry or by anyone in Tracker, it might be problematic because it might be a totally different signature, and in telemetry we on the server side we just recalculate a V2 signature. So this way we can group all of those SIG-V1's versions. So unless we have the raw data to calculate the second signature, we might miss that it's actually the same issue. And that's a problem that I see here. But in case it's the same, in case it's the exact same signature, the V1 signature, we will be able to say yes, for sure, it's the same crash. Mm-hmm. So once we have all of the changes for the second signature on the server side, we will update that on the client side as well. And within a couple of majors, we should have the same signatures both on the client and the server side. Yeah.
Mm-hmm.
Yeah.
Cool. All right. I think we are done with all the topics that were listed. Anybody have anything else? Should we just call it a night?
Let's call it.
Thanks. Call it. All right. Have a great night, everyone. See you.
Have a good one.
Everybody.
Bye. Thanks.
Bye. Thanks. See you. Bye.